Cool. Thank you all for coming. Thank you for leaving lunch. I know you started a little bit late, so you had to work hard to cram your calories in on time. I had hoped to give a presentation on the device in question, but the HDMI to VGA adapter wasn't working, so I'll be doing my backup instead. But just imagine that it's running on a 1.2 gigahertz CPU with a little embedded Broadcom GPU. Down. There we go. Cool. So I always like to start a talk with a little bit of an overview, the big questions. Who are you? Who am I? Why am I here? So just to get to know you guys a little bit. Who here is a developer who works on IoT platforms? Anybody write code? Okay, a few of you. Good, good, excellent. Thank you for coming. So yeah, this is targeted at people who are doing appliances, digital signage, kiosks, these kinds of things. Those are the most common usages of kind of IoT platforms in this space. But I think as we start seeing IoT move throughout the marketplace, you see new things coming in. I'll get into that in a second. My name is Ben Garney. I'm giving you the talk today. So I started out in game middleware space. I was the Torque Technologies director at Garage Games for about 5 years. Provided technology for tens of thousands of small game teams that were building titles in the early 2000s, did some console work. That company sold, went on to start a company called Push Button Labs, which was technology and games in the social game space, so Zynga and Facebook games and Farmville and that kind of stuff. That was a cool experience. I did some open source middleware there that was used by a bunch of the major players in the space. And in March of 2010, there were 60 million users who had play experiences powered by the tech. So if I got a penny per user, I wouldn't be here. I'd be on my yacht. But it was still a cool experience, and it was neat to operate at scale. And as you know, scale is a big part of IoT, right? Maybe not on the device end, but on the back end, you do have a large volume of requests. So step 3 in my career is starting a company called the Engine Company. So we have 2 pieces to the business. We do a product called the Loom SDK, which I'll sort of talk about indirectly a little later on. And then we also do consulting. So we've done work for Novotel and Disney and Dolby and Adobe and a bunch of other big companies on embedded systems, weird little prototype devices. We also do VR and AR work and things like that. So that's kind of the big questions, hopefully, as you come out of lunch. And the Engine Company, as pictured. Yeah, no problem. So use cases, most IoT, I think that has a big visual element. You see digital signage, you see museum installations, you see appliances, both literally like a smart fridge, as well as maybe less obvious. You know, you could imagine your furnace has a little screen on it that you can configure things, or your thermostat. Obviously, a lot of those now have, real touch screens on them. A lot of devices now tend to sort of be the, tablet bolted onto a thing kind of form factor. Like you see a lot of printers like that where they have like a little separate tablet piece that's mounted. But I think as the capabilities that are embedded become more ubiquitous and more powerful, you're going to see more of these kinds of interactive displays on devices. So if you are doing something like that, you have a lot of options. There's a lot of consumer embedded systems available. You can be on your Raspberry Pi. You could be on BeagleBone Black if you're a little more industrial. There's lots of system-on-a-chip vendors that want to sell you stuff. You could be doing a Qualcomm-based system, or it could be many other vendors. NVIDIA would love to sell you something high-end if you have the budget in your BOM to build it in. Operating system-wise, Linux is where it's at. I've pretty much universally in all the recent era of Internet of Things stuff, that seems to be where people are focusing their effort. There's some real-time OS, some proprietary OS stuff, but you just don't see it in consumer devices that much. Maybe if you're doing the Mars rover, you're running some specialty builds of Unix, but Wind River or something like that. But otherwise, it's going to be POSIX and it's probably going to be Linux. And then graphics-wise, either you're doing a software renderer or you're doing OpenGL, or if you're really cutting edge, maybe you're using Vulkan and trying to save a little bit on complexity and thermal overhead for the CPU. So there's a lot of different choices that you have as you're building IoT stuff, and that kind of sets the frame for the discussion here. You have a goal. I want to present visuals. I want it to be interactive. I want it to be responsive. I want people to have, be able to operate the device in a way that makes sense without spending a ton of development budget. So you have to, make some choices in there, and I'll talk about that. So WebKit is super popular. It's a really easy choice. I think it's actually probably the worst possible choice on most embedded systems. It's for a number of reasons, which I'll get into, and driven by that's been my experience with it, as well as you'll see I have some other reasons for thinking that. So the biggest reason is just that it adds a lot of abstraction over what the hardware is doing. And when you're running on one of these lower end devices, you're not in the position of having a lot of flexibility. You don't have a lot of CPU cycles to burn, especially if you're doing something useful with a device in addition to what you, the user interface you want to present. Just in debugging it, there's a lot of indirect behavior that's very difficult to debug or control. It's a huge code base, which means that if you want to, God forbid, understand or change something, you might, unless you have WebKit experts on your team, you're looking at a substantial effort to figure out what's going on. So I want to talk about a few different projects that I've done recently and why they sort of fueled my hatred of WebKit. So the first one is we did a project for a company that was working with Samsung, and so we did one of the Samsung watches before it was released. We were working with it, and we were building a hotel booking experience. And so it was actually a really interesting project, both to imagine what does it mean to book a hotel from your watch, but also how do we present kind of a snazzy, consumer-oriented experience that people would want to use. And it was really rough. WebKit, you're on like a 1 gigahertz. I think we might have had 2 cores, but you didn't really get both of the cores experience. And you're trying to do animations. You're trying to have things be circular because it's a watch, and you can't just do boxes for everything. You have to run all the touch logic. And so, we spent, I don't know, about 3 or 4 weeks building the application, and then about 2 months optimizing it, working around bugs in the platform. And so it's a little better now that the device is released, but it was rough, and performance ended up being the limiting factor for what we were trying to do. We also did another project, desktop front-end application, so just your typical web app. And that was actually pretty nice because you're on a 2-3 gigahertz system, you have a lot of resources, you can cache things, and it runs well. So WebKit can be effective, right? As a stack, HTML5 is powerful, and you can do a lot of good stuff with it. But even then, it has weird limitations. We tried to do kind of a little portfolio site, and we thought, well, why not have like a full screen gear that spins around as you're going through the site? That's sort of a neat background element. And that also took a month of work to kind of get running smoothly across devices. And it kind of came down to different browsers do different things. WebGL works differently. They're not all tuned for smooth performance. So you got all these issues. And so the last sort of example is we participated in the City of Eugene hackathon, and we did an IoT-based kiosk application. So the idea was basically you'd have a kiosk in the street, and people could come and find local events and see what was going on. And so that was a really cool weekend to work on stuff, but we didn't use WebKit for that. We used some native technology. And so it was great because you knew if you were drawing something, you knew what the cost was. You didn't have things running in the background that were complicating tuning the application, and you could sort of budget what you were doing. So when you went to run updates or do sensing or other things, you had a kind of a consistent behavior there, as opposed to like, oh, the browser is rebooting right now, your sensor readings are delayed, or it consumed all the RAM and so nothing's happening, that kind of stuff. So that's kind of a little bit of my background. So then the question becomes, if you're not going to use WebKit, what are you going to use? So there's a bunch of technology out there. There's Qt, there's Marmalade, there's proprietary software rendering stacks, there's digital signage platforms, which have sort of universally been horrific in my experience, but certainly people do build things with them. But I'm like kind of old school, so, and coming from games especially, I said, okay, well, I think I can, there's something better to be done here. So I think the best thing to do on this class of devices is to have a native runtime. Choose a good scripting language, a JavaScript or a Lua. Use some of the open source rendering libraries that are available, like SDL is an excellent choice because it's very Linux oriented. NanoVG is a great library, so that would be the eyeballs looking at you. That gives you vector graphics and high quality font rendering, which is pretty essential for a broad variety of applications. integrate with a map provider, use SQLite if you need a little database. And so all of a sudden you're taking pretty proven pieces and you're puzzling them together to create a solution that fits the platform really well. You're not trying to like bend this tiny little device into being a really fluent web-based experience. You're saying, actually all I really need to draw are some text strings, a couple of images. I don't need 400 kilobytes of CSS to tell me where to put everything. Like I just want it here. I was on a panel a couple of years ago with which was HTML versus native, and one of the guys was an HTML developer, and he was talking about how they had just he just about finished this great library to operate in CSS and go in and reset everything so it would work smoothly and be sort of like a blank slate. He's like, it's only like 15K of CSS that you have to include on every web page to make this work, and then you can finally position things on the screen. And so I said, well, how do you do it, Ben? And it's like, well, in the programs I write, you just set X to what you want it to be, and then it works. That works pretty well. So there's a lot of nice things about this approach, which I'll get into in a minute. Also, workflow and tooling. HTML and JavaScript are nice to edit, but they may not be the best option. It may be really appealing to have the ability to develop on desktop and deploy directly to device. And you may also have a desire for an IDE, a debugger, depending on the variant of WebKit you're running and the specific situation that you're working in. Sometimes you can get remote debugging off the device, sometimes not. It can be kind of hit or miss, but it's nice to have that sort of be a reliable part of the system. So, which comes back to performance. So, developing for embedded device is a lot like Genie and Aladdin, right? You have your phenomenal cosmic power, but your itty-bitty little living space, because you may have only a few hundred megs. You have the operating system doing stuff. There's a lot of competition for resources, and so the lighter and more consistent you can be, the better an experience you can offer. So performance is a huge concern, and as I've mentioned, basically on all these projects we spent an inordinate amount of time analyzing performance, looking into how things are working, making sure they're working consistently and we're not dropping frames, and that's all to kind of give the user an experience that they might enjoy having and not distract from the operation of the device. So I wrote a book on performance, which you could go find on Amazon, and it's for video games, but you can actually use it to optimize kind of whatever you want as sort of a general process. And in the context of different projects, we've written all sorts of tooling. So what's pictured here is a hierarchical profiler. So it actually shows, if you look at let's see, can I bring my mouse up? Can you guys see that? Oh, awesome. Okay, cool. So this actually shows each of these blocks as a function that's running in the course of a few microseconds, and who's calling what. And so you can go down and see, okay, who's taking up time and who's he calling and how many milliseconds or fractions of a millisecond are getting spent. And so you see this a lot in kernel development. They do the flame graph, and you can see time spent over duration of operation. Having this stuff built into your runtime is really valuable. WebKit has tooling. I mean, HTML has tooling for performance. It doesn't give you the full picture, though. It'll show you where your JavaScript time is going, but it won't necessarily show you where in the runtime time is being spent. And that can be really frustrating, because a lot of times on these devices, time goes into rendering, not into other parts of the system, right? So you're just like, well, the JavaScript took no time, and rendering took all the time. What happened? Why? And we saw that on the Watch project. We saw that on the portfolio site project. Just it's very consistent. And we didn't see it. The only reason we didn't see it on the web front end project is there's no animation on that page. So you actually do get a smooth browsing experience if you don't do anything. Some thoughts on performance. You're probably always going to be on the edge if you're doing anything graphical, even if you're behaving pretty well. If it's an interesting device, you're going to have back-end processes running, right? I mean, it's going to be doing something in addition to presenting a user interface. And so having a clear budget in terms of milliseconds for responsiveness, in terms of memory, is super valuable. And a lot of times on these devices, my experience is that there's not necessarily a clear budget, or it's a budget of maybe memory but not CPU, and so you kind of get a bad experience. Focusing on profiling, if you have the ability to profile throughout the lifetime of the product, that's going to lead to much better results. If you save it to the end, then all your chickens are going to come to roost at the end of the project when you try to clean everything up. And that's not a good time, especially when you're, again, trying to target such a limited system. And the system conspires against you. A lot of these embedded Linux systems aren't necessarily looking out for you. And so the attitude I've developed with them is, it's not paranoia if they're really out to get you. And a lot of the basic stuff on these systems works great. Your networking stack is fine, virtual memory works, the core operating system services work, but as soon as you try to bring up, the graphic drivers, you find out that you're not really running the real graphics drivers, you're running some sort of like open source clone of the graphics drivers that, doesn't do 3D or, does a lot of stuff in CPU that it shouldn't. So, for instance, on this Raspberry Pi device, we actually had to spend a bunch of time figuring out how to configure Linux to actually pull down the closed source graphics drivers that would allow you to render stuff efficiently. And similarly with BeagleBone Black, we had to spend, I think I did a demo for Novotel on that platform because we were using it for some products, and I think I wrote the demo in about 2 days, and then I spent about a month and a half tracking down how do you actually configure the drivers to run efficiently so that I could get 60 hertz, or 30 or whatever the display I was trying to drive was. And so these sorts of things are a huge stumbling block. I'd love to see the driver community on Linux mature. It's usually not a priority for the people who are developing systems, especially the guys who are actually writing this stuff. They get it good enough to run X, and then they're done. But if you want to do more interesting stuff, you really don't want to be stuck running in X, and you don't want to be stuck doing it in software. You want to have access to what the hardware can actually do. So that can be exciting. And GPU bugs are fairly common. Like even bringing up on the Raspberry Pi 2, which is pretty well supported as a pretty known piece of hardware, we found that the shader compiler had bugs, and we had to do certain things to work around it, and certain operations didn't work. And so, these are like sources of fun as you're trying to deliver experiences on these platforms. So production concerns. This is my use up time slide, because I could probably talk about any of these for as long as I want. So is it okay if I kind of end at 1:35? Is that like a fair? Okay, so I'll wrap this up in about the next 5 minutes, and we can do questions and go from there. So yeah, driver bugs, GPU bugs are horrific. It's very difficult to debug. It's much easier to find a workaround. That's an issue that we run into a lot. Thermal is an ongoing concern both in mobile and IoT applications. You look at this thing, and if I was slick, I would have put the heat sink on, right? But I didn't. And you may not have that in your application because it may cost you an extra 5 cents per device to do it. So, then you really may operate at the limits of the device. And so now performance is important not because you want to achieve a high frame rate, but because you have to restrict yourself in terms of energy, right? You don't want to consume your whole battery. You don't want to blow through your thermal budget and get throttled by the system while you're delivering your experience. You have to be very meager in terms of the resources that you use. Remote update and management and system configuration are frequent concerns. This is more generic. You guys have probably dealt with this. You probably have systems in your IoT deployments to deal with it, unless you're one of the companies in the keynote, in which case you just don't, and you're fine. Having a way to do that smoothly is really valuable, especially if you're deploying fleets in an enterprise situation. There's Chef and there's other things that'll let you do that. Having a cellular modem where you can download updates at off-peak hours is really great because you can save a lot of money on bandwidth that way. Having a good logging system that's user accessible is valuable. We wrote one of those a couple months ago, and getting it so that everything was filtered out and you got nice displays, but you could ramp up the verbosity based on the user need. Getting that right took time. And we sort of had to do it because otherwise when we went into production and people bought it and were using the system, it's really hard to answer the question, why doesn't it work when you can't get anything back from the device? Crash tracking analytics. If you are an always-on device, having some idea what are people doing in the application, super valuable, and also getting those call stacks back, right? If you can get your core dumps back in some way, you have a much greater opportunity to kind of refine your platform as you're building it, and that's extremely valuable. Internet can go down. TCP is great, but TCP doesn't actually, account for when your internet breaks and you're losing stuff and your connections drop all the time. So making sure that aspect of your product is robust will take you a bunch of time and effort. And then you just have, field support. Dust gets in the system, power failures, all that kind of stuff. You know, in my case, I have a nice big battery pack, which I was going to run the Raspberry Pi off of so that I wouldn't have to worry about any sort of power issues or if they didn't have a spare adapter. In the field, you know, you may have a battery backup that's enough to be able to shut down cleanly, or you just test and make sure you're fairly robust in the presence of power failure. UI framework bugs, which leads to resource exhaustion. You know, as you're building these things, especially if you're doing like an X-based system, you know, you have to be careful that you're not using up handles, using up memory, fragmenting memory. I had a product I worked on where we would run fine on one set of graphics devices, but on a different set, after a while, it would crash the driver. And it turned out that we were fragmenting the address space on that particular graphics device, and so what we had to do is change all of our allocations to be powers of 2, and then magically, you know, we could run for as long as we wanted without a crash. So, you know, as an IoT device generally is always on, so you have to kind of be thinking about this stuff. Certificates, you have to be prepared to pin your certificates, you have to be prepared to actually check and validate them, you know, if you're running a secure system. That one's really easy to overlook, and frankly, when you're using a WebKit, it can be a huge pain in the butt. The disk will fill up, you have to have a policy to clean it out sometimes so that your log doesn't fill up the system and kill you. And then there's also the botnet risk, right? Security certifications. And you know, given the frequency of that now, I think everybody who knows about it sort of owes an obligation to resolve it. So I wrote an open source framework. It's called Loom. It actually does all this native stuff that I was talking about. If you're into graphics on IoT, you should check it out. We have Raspberry Pi and everything else. It's MIT. It's free to use. You might get a kick out of it. There's some workflow stuff we do alongside of it that's pretty cool as well. So that's what I actually used to write the Raspberry Pi version of the talk that's not working. And I'll be posting that as an open source version of the talk. So you might be interested to check it out. My blog, bengarnia.com, also worth checking out. So hopefully I've kind of given you guys in broad strokes an idea of if you're doing visual stuff on IoT, how do you want to build your app? What are the concerns when you actually try to ship it and have to take it from it mostly works to it really works, and how to run in production? You know, my strategy is I want to minimize my dependency footprint as much as I can so I can actually control what's going on. I want to set up tooling and procedures so that as I approach ship, I have a smooth path to delivery instead of having to, like, you know, suddenly ramp up effort to clean things up. And when you're in production, you want to get that feedback loop going so that you're able to refine and improve the system that you built. Because if you just fire and forget, you're going to make the same mistakes over and over again. So that's my talk, my Twitter, my email. If you have any questions, thank you for coming, and I'd love to answer any questions.
Thank you for your presentation.
Thank you.
I'm a professor here at IIT, working in the IoT space. I had a quick question when you mentioned at least the 2 platforms, Raspberry Pi 2 and 3. Seeing as those are ARM platforms.
One could view them as ARM problems, depending how frustrating they're being.
What would be the alternative to just using smaller x86? You know, VIA has fanless 1 gigahertz things that are like physically the same size. And then you can maybe deal with an x86 stack. Then you're dealing with integrated graphics. But what was your deciding to go that way versus x86, a smaller platform?
Yeah, so we do support x86, you know, in terms of this tech that I've been talking about. So in that sense, oh, sorry, is this better? So we're not. The fact that the examples I gave were ARM is not necessarily a strong choice. Most of the time when I've seen people doing x86, it's in the context of like a small Windows system.
Right.
And I think that's actually a really bad choice for embedded. Maybe the newest generation is a little better, but historically, like having a little Windows 95 box in your kiosk was a source of pain and cost for everybody involved.
What's your thought about x86 Linux?
Yeah, so you know, in these sort of small form factors, if thermal and power aren't a concern and you can get a good price on it, I don't think there's anything wrong with it. You know, Intel integrated graphics, you know, I'm not intimately familiar with the capabilities they ship in like the VIA chipset, but most of the stuff that we've done it's not about GPU horsepower, really.
Yeah.
You know, it's just like, can you draw, you know, do you have enough fill rate to kind of draw the scene that you want to draw? But if I was in a battery-powered device or one with thermal constraints, you know, it seems that ARM is still better in that use case, and so I would probably veer that way. But I know that Intel's, you know, continuing to roll out IoT devices from time to time, so I certainly evaluate it if I was looking at platforms.
And then one follow-up question: would like BSD, FreeBSD be an option, and/or does System D? You know, some of the newer Raspberry Pi distros and Linux distros have gone whole in on System D. Does that complicate? Because your NIT systems are different. It's a different ball of wax.
Yeah, that's a great question as well. So, I mean, a great partial answer to that is this guy's running a standard Raspbian. I have another micro SD card that actually runs a little super trimmed down version of Linux that just has enough brains to bring up the runtime for the presentation. The downside was it only had the graphics drivers for the Raspberry Pi 2 because that was what I was originally planning on using, and then I had to switch to the Pi 3. But you know, I think in general, if you're doing that kind of IoT application, having a really trimmed down runtime in terms of what you include in Linux and what you ship is smart. You save resources, save disk space, save startup time, and you hopefully expose yourself to fewer vulnerabilities. So I would, you know, for any sort of serious IoT device, I would absolutely advocate, you know, shrinking down your Linux distro as much as you possibly can.
And are you yay System D, nay System D? Or in your domain space, does it not factor
neutral.
in?
As long as processes start up at some point,
got it.
I'm happy.
Okay.
Yeah.
Thank you very much.
Yeah, my pleasure. And any other questions I can answer?
Any other questions?
So your emphasis was on creating a visual interface for smart devices, right?
Yeah.
And you choose your option LUA versus HTML5, right?
Yeah.
Because
why not HTML5 or?
I thought at one point at your presentation that you said that no CSS, no HTML5, but then you're limited to whatever you can run your app on. So for you to see it visual, you need to have the app installed in your devices versus HTML5, which is a common for all of them, tablets, phones, web.
Oh, sure. Yeah,
So right now you're kind of going backwards versus where everybody goes. All the
Right.
automation, all the smart devices are EtherCAT, right? Ethernet Cat5 devices, and you decided to choose the emphasis on a visual with your software, which is software-based dependent, which is operating system dependent. Can you explain why?
Yeah, so I definitely wouldn't recommend this approach for like an admin interface for a device. So if you want to have a web, you know, say you're a smart camera and you just want to have a little web page where you can set the settings on the camera, which I think is more the use case you're maybe describing, as opposed to like a fridge where there's like a panel on the fridge or something like that. So in the admin interface case, of course, web is great because anybody can access it. There's no screen on the device anyway, so you don't care about visual stuff on it. If you're doing visual stuff on the device, so we actually also support mobile. We actually started out on mobile and then have added IoT support. So you could certainly build a system that, with these sorts of runtimes very easily, that would be on. You'd have an app version. You'd have this. You'd have that. For ubiquity, definitely, if you want to make a smart device that can just consume kind of arbitrary applications without install or configuration, then it's worth it to sacrifice fidelity for ubiquity, right? And go with an HTML5 capable setup or a WebKit capable setup and say, so you're not going to have a really awesome visual experience, or the developer may have to work hard to give you an awesome visual experience, but you can just load whatever you want, so you have flexibility. And even in my own career outside of IoT, there have been times when we've focused on native applications, but then the social era, the reason why that era was so successful for gaming was it was ubiquitous. You could make a web-based application with Flash, everybody could play it, everybody could run it. So, there's always that balance of ubiquity and fidelity. This is useful for a certain region of that, or this approach is useful for a certain region of that. There will be times where it's okay, it's worth it to go with WebKit because more people can use it. But I'd say in general, if you're a focused device that has one user interface that you want to present to people and it runs on device, I would definitely tend native as opposed to just preferring to go with the WebKit. Yeah, does that answer your question?
Yes, thank
Yeah, my pleasure. Do we have time for one more question? If there is one more.
Anybody else? I have one question
Yes.
related to the power analysis you kind of made there. All this analysis was made only from the graphics, compute, and rendering standpoint, or is it applicable? This analysis is also useful for any other power-intensive constrained environment, IoT.
So you're talking about focusing on performance as a way to reduce energy consumption?
Correct.
Yeah, so for this one, these sets of applications, we definitely focused on the combined, what is the runtime doing, what are all the pieces doing picture, and trying to kind of minimize usage to get maximum energy efficiency. But you see that, as you know, you see that everywhere, right? You see it in Bluetooth beacons. The less often the beacon runs, the longer it lasts. Mm-hmm. If you have a battery-powered device, the less often it fires, the longer it'll last. And with thermal distribution, in this class of system, we didn't see a lot of energy usage in areas outside of that, so we didn't focus on it. But you could imagine like a BeagleBone Black, where it has the co-processors that are doing real-time processing. Maybe you need to spend time focusing on the energy there as well to hit your desired lifetime off a battery. So I think it's a pervasive concern anywhere you're doing anything complex, and you have to have tooling that lets you go in and start getting that energy breakdown so you can tune appropriately. Okay.
So in the typical IoT model, this is a different question. Mm-hmm. This is more like an actuator providing a service of graphic rendering more than a sensor of any kind, correct? I'm just trying to classify what kind of IoT device this would make.
So you're saying, what if you have an, like a Raspberry Pi type system powering a robot platform or something like that? Or yeah. So I think it's very interesting to consider that sort of stuff. I think as you have robotics, especially in the home or factory settings, having feedback is really valuable. Having a screen or some other way for it to communicate is valuable. And at the same time, if it's a self-powered device, when you're doing your motion planning, thinking about energy efficiency becomes valuable, right? There's a high energy way of getting over a wall and the low energy way of getting over a wall. So I think as we see those sorts of systems become more common, definitely that'll be a factor in their algorithms.
Thank you.
Thank you very much.
Thanks.
Thank you.